Hello. Oh, that's a bit loud, I'm sorry. Good morning. If you were not awake, you might be awake by now. Thanks for being here. Great to see quite a lot of people, even though it's 9 o'clock. And we had a party yesterday night. Nice to see all of you. My name is Maarten. I work at a Dutch company called InfoSupport. We mainly do consulting. We also do data science ever since before it was actually hip and happening. But today I'm going to talk with you about React Native and how you can build cross-platform mobile applications with that. So to get started, I want to take you back to a childhood memory of mine, which is this TV game. And I used to watch it when I was a little kid. Yeah, we do have the best TV shows in the Netherlands, it's true. It's actually a pretty simple game. You have to guess a word of 5 letters. Couldn't be that hard, right? And as a bonus, you will have 1 letter when you start. For example, you will have the W on the 2nd position. So you need to guess a word of 5 letters with W on the 2nd position. Well, my first guess is Sorn. So I'm spelling it out, S-W-O-R-N. And I get 2 red squares, saying it's the right letter and it's on the right location as well. Great. Next try. Maybe it's sort. It's not a really good guess because the O and the R were not highlighted, meaning they're not in the word at all. So sort, and now the D is highlighted with a yellow circle, saying it's the right letter, but it's not in the right location. So, any next guess? Sweet. I hope somebody would say that. Yes, it's great. You could play the game as well. See, it's that easy. And when I wanted to investigate React Native and was looking for a nice case, like how can I try to get my fingers around it and understand how it works, I needed to think about this game because it's simple. There's no complex graphics. There's no complex gameplay. There's no multiplayering whatsoever. It's pretty simple. The rules are simple, so I can focus on the technology instead of doing all the complex stuff. So React Native, what is it like? And just a quick warning, I'm going to do some live demos. They might succeed, they might not. Please do not blame me for that, although maybe I am to blame for that. Anyway, we'll see. If you want to get started with React Native, you'll install the tooling. You can find that on the website of React Native. And the first thing you'll usually do is you start with React-Native init, followed by the name of your application. And it will then generate some boilerplate for you with an application. And you can then run it on an emulator, for example. I'm having a MacBook, as you can see, so I have an emulator for both Android and iOS. If you're running Windows or Linux, well, you can only run the Android emulator. I've already issued those commands. I've built the application for the first time because if I would not have done that, we had a very boring presentation because you would need to wait for minutes. That's not fun. So let's see. I generated the application, and here's a very simple application. I hope that even if you're in the back of the room, you can read the code. Can you? Great. Well, thank you. So, what do we see here? Well, it's a greeting component. There's text elements. It shows some things called props. And we have another component which is called app, and it is doing something with the greeting. And don't worry if you don't get all the code exactly immediately the first time, because we'll be looking at how it works and what it does. And now if I will start, I will look at my emulator. Where is it? Here's my iOS emulator. I hope it's still visible back there. And here's my Android emulator, which seems to have some issues with the beamer, apparently. Wow. we'll just restart that. It's probably quicker. Fingers crossed. But in the meantime, we can look at the code for a little bit. As you can see, there's 3 text elements here in the code. They're using props, and they are reading something from the props. And we can also see that if we use our component, our greeting component, we can specify parameters for this component. In this case, we're specifying the city and the name. And we can see that the city is reflected there in the props, as is the name. And we can easily add more text if we like. Let's see if the emulators are catching up already. Yes, great. Now the good thing is that if you change your code, you do not need to rebuild your application. For example, on Android, I can just reload my application and I have a lot of more text immediately. That's a very quick feedback cycle there. And on iOS, no surprise probably, I can do the same thing, reload my application, and within seconds, I can see what the effect is of my code change, whether it looks the way I expected it to look, and whether it behaves the way I expect it to behave. So, before we go any further, you might be aware of other tools that exist to build mobile applications for multiple platforms at the same time. For example, there's Cordova or PhoneGap. It depends on whether you're using the open source edition or the Adobe version. So let's take a quick look. What's different there? Cordova or PhoneGap are based on HTML, JavaScript, and CSS. That means you build an application using techniques you're probably pretty familiar with. I think, if I remember correctly, it's using Angular under the hood. And, well, that's a good thing because we're familiar with that. We can easily get started. But then if you want to run your application, well, it turns out that my application is actually a web application, of course, running inside a browser, running inside my application, which, well, may not be the exact native feeling I'm looking for. It may also be from a user perspective that, well, things do not work exactly as you would expect it. Hey, my button, my back button on my device, my hardware button is behaving differently than I would have expected, for example. Another tool that's also rather popular last month is Xamarin. Since it got open sourced by Microsoft, it has gained some popularity there. If you're used to C#, it's a good fit maybe because it requires you to write your application in C#. As for me personally, that would be rather challenging because I don't know a word of C# except the C and the sharp maybe. But that's all there is to it. And the second thing that I personally don't quite like is the fact that it also ships a mono runtime, which does make sense because the C# code needs to be run somewhere, and just like Java, it's a managed language, so it needs some kind of runtime, but it's packaged with your application. So let's look at React internals, how it works, and see where it's different from, for example, PhoneGap or Xamarin. We'll be looking at how the application starts, how it is executed, and what's happening at runtime there. First of all, how is the application starting? When your application starts, for example, because you've pushed an icon on your home screen, the operating system will load your application. And your application in the React Native world actually is a combination of 3 things. It has some native modules. It has a JavaScript VM. or not. We'll see that later. And it has a JavaScript bundle, because in React Native, my whole application is written in JavaScript. So these three things will be loaded, and the native modules and the JavaScript VM will be combined. When both of them are loaded, the system will parse a configuration block, which is typically provided in JSON. As a developer, you don't always need to know where this JSON is and what you can change, but it's good to know that there is a way to modify that. And if the configuration has been loaded and your JavaScript bundle has been loaded, you're finally at a stage where the JavaScript bundle can actually be executed. Which brings us to the next step, the execution of the JavaScript bundle. As I said, your application may or may not contain a JavaScript VM. It's actually dependent on the platform, because on React Native uses the same JavaScript engine that also is available in Safari. It's called JavaScript Core. And on an iOS device, it's obviously there, because it has Safari, so it has a JavaScript engine from Safari. You're good to go. On Android, no Safari, no JavaScript Core, so it is packaged with your application, which will make your application a tiny bit bigger, but, well, we might have to pay that price. There's an exception to that rule if you're debugging your application locally, because, well, in the end, we always need to debug some moment in time. You'll not be running JavaScript Core, but you'll be debugging in Chrome, actually. And that means you're using the V8 JavaScript engine, which is under the hood of Chrome. And for the rest, it's actually a pretty boring story. How is JavaScript being executed? It's the general paradigm of parsing the JavaScript, generating an abstract syntax tree, generating bytecode from that syntax tree, and then running the bytecode. Nothing special there. We won't dive into too much details. And then the last part we need to know is, how does this JavaScript create a native application? Because it's called React Native, and I've been saying native application quite a few times until now. So how does that combine? JavaScript and native do not seem to be the same thing. As I said, your JavaScript bundle will be executed, and it will trigger a few things. It will load some kind of a bridge, and we'll get back to that. It will create native views. As we can see, it will create shadow views, which will in turn create a layout. And the layout, together with the native views, will eventually be displayed on your screen for you as an end user to see. Now that's one way, but the other way is obviously the user doing things, pressing a button, swiping, typing, you think of it. Those events are captured by the UI kit. The UI kit will in its turn invoke one of the native modules that comes with React Native, which will in turn trigger JavaScript code. For example, an event callback that you have declared in your application. And that is where the circle comes around and you are back in your JavaScript VM. So yes, it does create native UI elements for every component that you build. There's no web view, there's no browser view triggering things, mimicking a native view or whatsoever. It's the real native UI elements. And we saw that already with the first demo when I triggered the developer menu in both applications. I got something that's native to that platform. On Android, I had a black menu. On iOS, I had some white menu with rounded corners and blue letters, etc. It's pure native stuff there. So far so good, I hope. I don't see too many people sleeping, so I hope you're still with me. Let's look at how we can build our application with React Native. And for that, we will look into 3 topics. We will look at how React actually works. Because if you know React, you know React Native. We'll look at how to style your application, and we'll look at how to manage state. And for the last topic, I'll be introducing Radix as well. So first things first, React. React is a library from that was developed by Facebook, and they open sourced it. And React is actually a way to build user interfaces for web applications in a declarative way. That means you're not instantiating components yourself, you're just declaring that your component is using other components in a certain way. And it's very important to keep that in mind, that React is actually component-based. So it tries to stimulate you to write components that can be reused. Let's look at a quick example of React in a browser environment. This looks a bit like what we saw in the first demo. There's two components, the hello message, which has a render function, and there's an app component which also has a render function. Now, don't get scared by the syntax. We'll get to that in a minute. But let's just assume that, well, we have some kind of inheritance, which is indicated by the extends keyword, and by the fact that we're using classes, which is not there in JavaScript, I know. And if we want to boot this very simple application in our browser, we'll just ask React to render our application component somewhere in the DOM. Nothing special there. This document getElementById is just plain old JavaScript to fetch an element from the DOM. And it will attempt to render the app component, which will in turn render the hello message component. And well, we can easily predict what it's going to do. It's going to greet us, hello JFocus, great. As I said, don't be scared by the syntax. This is two new technologies being used at the same time, because we're using both ECMAScript 6 here, as well as JSX. Let's look at that. Let's just take the hello message as an example. As I said, ECMAScript 6, which is the not yet final specification for what JavaScript might be going to look like, it introduces, among a lot of other things, classes and inheritance. We could factor that out, in fact. We could just write plain old ECMAScript 5. We have no classes then, we have no inheritance then, so we would write the code a bit different, and we would just invoke the create class helper method that comes with React, and we would tell it to have a render function which will return our markup there. Starts to look a bit more familiar maybe, because, well, okay, can pretty much figure what it does, except for this return statement, because it returns a div. And no, this is not a typo. It shouldn't have return a string with the contents. No, it's actually returning XML, and that's where JSX comes in. JSX is a way to embed XML in JavaScript. We could factor that out as well. And it would look something like this. It would invoke the createElement method of React. It would tell to create a div element with some content at the end. Excuse me. So that's how the magic happens under the hood, because ECMAScript 6 is not supported by most JavaScript runtimes either. And you often need tools like Babel to transpile your ECMAScript 6 code into ECMAScript 5 code. And we'll also take care of demystifying the JSX and replacing it with plain old JavaScript function calls. I do like the AS6 and JSX combination, however, because it gives a much shorter code. To me, it's way easier to understand what the uppermost sample does than trying to interpret what the lowest example does. There's a lot less incidental detail in there. It just declares what I want to do instead of specifying how it exactly needs to be done. But the good thing is, you don't have to. You can write your code without ECMAScript 6, and you can write your code without JSX. And you can still build a React Native application without these newfangled technologies. And you could even do a gradual transformation where you start with just your plain old JavaScript that you know and love, and then gradually transform in the direction of using AS6 and JSX. Next thing, how do we style our application? As I said, a React Native application does not run in a browser, so we don't have CSS. And if we don't have CSS, how can we style our application? That's the only way to style things, right? Or, well, maybe it's not. Turns out that the React Native guys have thought of something which they call style sheets. That's a pretty original name. Style sheet is also shipped with React Native, and you can create a style sheet, and this is a very trivial one, of course, which will just define one style, the style red. And this red style has a color property with the value red, or you could specify it using color codes or even RGB codes, never mind. And then the next question pops up, how do I use these styles? Well, I can supply the style as a property to my component by just referring to it. And as you can see, I'm referring to the red style of my combined style sheet. Now, there's actually two ways to do this. This is a very simple example. We have one style, we have one component. You could have one global style sheet for the whole of your application, but that will quickly run out of hands, because if you're writing more than a toy project, you'll have quite a lot of styles for maybe just one individual component, never to be applied anywhere else, but it just fixes this itchy little thingy. If you would put it all in one global style sheet, you'll create some kind of a style sheet monolith, which, well, we don't like monoliths actually. The other way, which I personally prefer, is to have your styles together with the component, which makes it easier to see if you're looking at a component, what it will more or less be looking like. Because there's no such thing as inheritance or cascading in these style sheets. If my component is inside another component, it does not inherit most of its style properties. So that's something to keep in mind. And the last thing I wanted to cover is how to manage your application state. I'm having a simple diagram over there, which may be what your application looks like, but this is still a pretty simple application. It has some kind of a loading screen, which will probably be displayed while fetching data from some external resource. It will create a list view, and then the list view will populate some items. Shouldn't be too special there, that we can all think of applications that look like this. But now the question arises, where do I keep my state? Should I keep it in the application? That might be one approach to do it. We can just put it there and just pass it down using these props that we saw. That's obviously the way to parameterize components and to make them behave differently. But that would mean that the loading screen needs to know about the data that's inside the list view. And that would mean that the list view needs not only to know about the list of data that's to be displayed, but also about maybe event callbacks. Like what happens if I click my item number 3? I don't actually want to pass down my state through all of my components, because if I would do it that way, I would have a very strongly coupled component tree. My component tree would know of each and every detail of the components below it. We don't like that. And this is where Redux comes in. Before we look at Redux, I need to mention it's not tied to React Native. It's not even tied to React, in fact. You can run it outside React and React Native and it will still work beautifully. And why beautifully? Well, we'll see that in a minute. Redux is based on 3 core principles. And the first principle is that the state of your application is a single source of truth. This means you are not supposed to make a copy of it. There's just one JavaScript object that lives somewhere, and that defines the current state of your application, period. There is no such thing as alternative facts. Second thing is that this state is a read-only object. Means you're not supposed to mutate it. You're not supposed to change this state. And oh wait, that's difficult, because if my state is read-only, I'm having a pretty boring application, right? You're not. You can mutate the state by emitting an action. And an action is just a simple JavaScript object which has a type property, which has some kind of a name that identifies it, and it might also have some parameters. And then these actions are processed by Radix, and by giving Radix some reducers, you can specify what the effect is of a certain action to the state of the application. A reducer is just a function. This function takes the current state as the first parameter and the action that's being processed as the second parameter. And might your action have parameters as well? You'll get these two because you get the action, not the type of the action. And a reducer always returns a new object. And that's very, very important to keep that in mind. It's a pure function, it's not allowed to have side effects, so it may not change the first parameter, the current state. Remember, the current state is read-only, and you're not changing that. The good news is that a pure function is perfect for testing. As we all know, pure functions, we love them. Functional programming, yay. And you can easily test them, for example, and see that they indeed mutate the state of your application in the way that you expect them to do. So let's look at an example. Fits perfectly. This is just Radix without anything else. No React, no React Native. I did use ECMAScript 6 though, because it makes the code a lot more compact, otherwise it might not have fitted on the screen, and that would be a shame. So what do we see here? First of all, we import Radix, or at least we import one function from Radix, which is called the createStore function. We also define what our initial state looks like. It's an object with one property to do's, and that is an empty array. Great so far. Now, if we look at the reducer, it's just one reducer that we are using here, and this reducer gets the state and the action. It's a function, and it will do something with these two parameters. And we're using another special thing, which is we're saying if state is not supplied, it has a default value, which is the initial state, which is just a shortcut way to prevent having to initialize your state. Now, we ask Radix to create a store. The store is where the current state of the application lives. And we're specifying our reducer. Let's look at the reducer for a second. As I said, you'll get an action as the second parameter of your reducer. And this action always has a type property. Well, we can look at this type property and see what its value is. For example, if we have add to do, we can create a new to-do item on my perfect, awesome task list. We determine what its identifying value will be. We take a title as some kind of text like what I need to do, and initially we'll mark it as not completed. Would be nice, a task list that automatically completes your tasks for you, but this one doesn't. And we're specifying the ID as well. This is a shorthand notation as well. By just saying ID, I'm actually saying there's an ID property and its value is my local variable ID. So I could also have written this, but that's 3 more characters. Similar for the complete to-do action, it has some kind of a extra parameter, which is the ID of the action that I want to complete. I'm creating a new to-dos array here. Remember, I'm not allowed to change the state. So if I want to replace the state, I also need to make a copy of my original to-dos array. I'm not allowed to just remove one item from it, because that would, in fact, change the state as we know it, and that's not allowed. So I'm returning a new object in the end with just a to-dos property in there. So back to the main code. I have my store, I have my reducer. Now I can dispatch an action into the store. For example, I can have a task that's called speak at JFocus. It's been on my wish list ever since I was young, so it makes sense to put it there. And we can then ask for the current state by just looking at getState. And we can we can dispatch another action where we complete the to-do, and we can again look at the state. Now let's see if we can run this code. Cool. Well, that's pretty much what I expected. I have a quick helper script because, as I said, this code is written with ECMAScript 6 constructions, and Node will by default not understand that. So what my build script does is just using Babel to transpile the ECMAScript 6 code into ECMAScript 5 code, and then I can run it. And as I can see, my first state is an array with one item on it, which is not completed. And then my second, when I invoke getState the second time, I have an object that seems almost the same, but it's not, because my task has been completed. And well, just 25 minutes or so, and it has indeed been completed. So it's a bit early to say completed already, but please forgive me. Now this is all nice and fine, but it gets actually better when you combine React with Radix. And the library that does this for you in a rather elegant way is called React Radix, because why think of an original name when you can just combine the two things? And what it does is it provides some kind of glue between the store from Radix and your component tree from React. And this glue is called a provider. So we import a provider from the React Radix library. We have our store, we supply it with a reducer. I'll skip all the details for that because we just saw that. And then in the end, we do not immediately start the application, but instead we start the provider, supply it with our store, and then inside the provider we have one component. In this case it's a loading screen, but could have been the application as well. Now that's all nice and fine, but how does this underlying component connect to the Radix store? We still didn't see that. And that's the second part, which is called the connect function, which is also part of React Radix. Let's just forget about the to-do list. Let's assume we have a very simple state. We have a state with just one counter. And we have a component which is written in an even more concise way than we saw before. It's just a function of the properties, because skip all the rest. This is actually a valid React component. And it will just return a text which says something like there are so many tasks. Now I need two more functions. The first function I need is a function that tells React Radix how the state, what the relation is between the state from Radix and the properties of my component. And in this case, it's pretty simple. We still have some to-dos in our state, apparently. So we can just look at the length of the to-dos array and supply that as the count property of the props that my counter will receive. And we need a second function, which is called map dispatch to props. It works in a similar way. We saw earlier that we can dispatch items into the Radix store. We can dispatch actions in the store, and they will mutate the state. And what we do here is we have a function that gives us a way to put things in the props object that will in turn invoke this dispatch function. So it's a higher order function. It's a function that returns an object that will in turn invoke functions, if you're still with me there. We're not displaying that here, but it's very useful for event handlers. You could think of a button in your component that you can click to reload a list. So if I click the button, I will dispatch a function that I will dispatch an action into my state that somehow triggers reloading my data. And finally, I'm exporting the connected component to my application. So I am exporting the counter component. That's just for testing purposes. You could also not export it, it will still work. But my default export here is the connected component. So it connects the two functions that will supply the props for my component based on the current application state and this magic dispatch function from Radix. It will connect those two to my component that will receive the props at the end of the day. So there's still some time left. Let's see what the game looks like, because I started with showing you this awesome game, or maybe not so awesome. It's up to you to decide. If you want to check out the code, it's on GitHub, so you're free to look at it, to clone it, to blame me for doing bad things with JavaScript. That's all fine with me. And I need to start it, obviously. And unfortunately, we still will have to wait for another build, because my demo is using a different version of React Native than this application is. I really need to restart the whole packaging thing. As you can see, it's reloading the JavaScript bundle, which is being packaged live at this very moment by the React Native packager. It will actually combine React Native and all the other libraries I'm using. And then finally, I'm greeted with my game. As I said, the TV show is called Lingo, so I thought, well, since you can take it with you, it's Lin2Go. And I can easily start a new game. Well, as we said, 5-letter words. And in this case, we're having a D at the second but last. Anyone who dares to make a guess? Well, I'm making a guess myself, and since I know which words are in there, I can easily guess. Hey, yay, I got it right. That's the disadvantage of having random words. Sometimes it's the word that you already know. We can give it another try. Oh, well, it's probably sweet again, right? Ah, that's unfair. Okay, one more try. Okay, it's not going to be sweet this time. Maybe it's Sorn, yeah. Oh, that's what does not exist. That's a bit of a pity. I have a very small list of words because if I would have had all English words consisting of 5 letters, this would be a very, very boring game to play live. So probably it's short again. And yes, I got it right this time. So if I will look at my statistics, well, it turns out I'm an awesome player because I won all my 6 games. Maybe I'm cheating a bit there. Anyway, under the hood, this all uses the React native tricks that we saw. It uses Radix. It emits actions into the state. It's not mutating the state itself. And it's using React Radix to connect these components to the application state. There is still time for some questions, so feel free, raise a hand. There's a microphone, so please wait until you have that one so that everyone can hear your question.
If you have a mix of React and regular JS application, can you still use Redux in a good way?
Yes, I think you can. For the React components, assuming we're talking about web applications, right? For the React components, you can use this React Radix combination, which will make your life quite a lot easier. But you can still supply this Radix store to other components in your application that are not managed by React. And they will have access to the store and they can call get state, or they can subscribe to state changes or and then respond accordingly. Does that answer your question? Thank you.
Can you access the camera, use the Wi-Fi, the database, these stuff that the native applications do?
Yes, you sure can. If you look at the React Native documentation, they have modules provided for, well, basically anything you would like to do with your phone. For example, the camera, you can save state persistently. For example, this high score thingy that we just saw, it will survive a reboot of the application by just writing it down in somewhere on a safe place. And these modules have a very nice property because they have a JavaScript API. So you can call them from your application as if it's just JavaScript, and under the hood it will see if we're running Android or iOS and invoke the according native code for that. So you don't need to worry about how a camera works on either iOS or Android. You can just access it, which makes it pretty easy to build one code base for both platforms.
So what about the cases where you have different GUI conventions, for example, on Android and iOS? Would you introduce conditionals and have different code blocks?
Interesting question. Because I've been talking about one code base and cross-platform all the time, but what if we want to make a difference? The good thing is you can have source files included only for a specific platform. So we've been seeing, for example, a app.js. If I would have app.ios.js, that version will be preferred over app.js. So I can do different things, for example, because the platform convention is to have a menu over there or react to the back button being pressed or whatsoever. So yes, you can be platform specific if you want.
About performance, how is it compared to pure native code for the platform?
I don't have any hard numbers for that, unfortunately. There is most likely some kind of an overhead because, well, you do need to boot a JavaScript VM and you do need to do the orchestration between the JavaScript code and the native modules. React Native does provide some development tools to profile your application to see where time is being spent. So what I did with React Native was in no way performance critical, so I didn't actually need these tools. But you could use them to see where time is being spent and what's happening under the hood. But I suppose there is a small overhead at runtime. I think the questions are, there are no questions left. Oh.
All right. Okay, I think it was a wonderful presentation, but I have this question about when it comes to the design, because it's very important for your users to actually feel that they are using an Android, or what's the help that React gives? Are they some complete templates, for example, that one can use, or how do you get it if you, for example, we are developers, sometimes we're so bad in doing this design stuff.
Yeah, we're not built to make designs, are we?
Yeah, so how do you get about that?
Yeah.
Somehow.
React Native itself does not provide anything above basic UI elements like a text input, like a list view. If I remember correctly, even something as a button is not included because it's too much platform dependent what it should look like. There's a couple of open source projects that try to step in this gap and fill it. For example, there's React Native Elements, which tries to give you, well, styled elements and all kind of helper things. There's even projects that build on top of React Native and, well, give you a setup build environment with all kinds of frequently used libraries included, and you're free to go. So React Native itself does not provide such a thing, and you're pretty much left on your own, actually, to find something that fits your needs.
Yes, I have a question about the rights for this type of software. Does it demand always all rights from the device?
I don't know from heart exactly. It does require, at least the development build that you use for building your application and debugging it in the on your machine, it will require network access because the JavaScript bundle is packaged on your host and your emulator is trying to download that bundle from the packager. So it requires network access. And for some of the modules that are provided, for example, camera access, you'll need extra access rights, obviously. And under the hood, there's still a very small Android project with just a build.gradle and all kinds of things that you use for building an Android application. So you can change the manifest if you want and just specify that you need additional rights. I'm not too familiar with iOS, but I suppose there's a similar mechanism there as well.
Okay, that seems to be all questions, and you'll be around a bit later, I suppose, if there's anything you think of. Thank you very much, Maarten, for your presentation.
Thanks so much.